Today I'm going to talk about the Bombelli and Stevin's notation, and IVT, which is the intermediate value theorem. The Bombelli's notation is very advanced among all the Asian notations. He is the first one who used notations for powers, which is more similar to the modern ones we are using now. For example, in Bombelli's notation, he used P for plus, M for minus, A for equal, and DI for imaginary number. The imaginary number is the square root of -1, which we sometimes use it to solve the square problems. Now we use I to represent the imaginary numbers. And for the last one, the n over an arc is x to the nth power. The Bombelli's method is very similar to the modern ones we are using now. Different to other previous notations, Bombelli included squares and cubes in his notation. He also had many symbols for plus, minus, and equal, although the way to represent them is different to ours now. The idea is basically the same. So I have a chart on the right to compare the difference of the modern notation and the Bombelli's notation. For example, the 5x we use now in Bombelli's notation is 1 over an arc over n5, which means 5x to the first power. It is the same for 5x squared and for the square roots. RQ means the square root of a number, and RC is the cubic root of a number. In calculus, IVT, the intermediate value theorem, is a very important method to check the answers. But in ancient times, the mathematicians like Stevin used IVT to figure out the answers of some square problems. So he first determined the approximate value of x. For instance, x is between number 4 and 5. Then we plug in decimals like 4.1, 4.2, 4.3 into the function and get the first decimal number. And then we repeat it again for the hundredth and thousandth value. For example, if we want to find the value of square root of 2, we could let x squared equals to 2. So we know the value of x is between 1 and 2. We plug in the values between these two numbers. The square of 1.1 is 1.21. Square of 1.2 is 1.44. Square of 1.3 is 1.69. Square of 1.4 is 1.96. And the square of 1.5 is 2.25. Now we can see the square of x reaches 2 at 1.5. So we get that the square root of 2 must exist between 1.4 and 1.5. And then we plug into 1.41, 1.42, and so on to figure out the hundredths place. And then we repeat it again for the thousandths place. Now we can do another example, which is more complex. X squared plus 2x minus 5 equals to 0. And x is between 1 and 2. When x equals to 1.1, fx is negative 1.59. X is 1.2, fx is negative 1.16. X is equal to 1.3, fx is negative 0.71. X is 1.4, fx equals to negative 0.24. And when x is 1.5, fx equals to 0.25, which is positive. X squared plus 2x minus 5 reaches 0 at the value of 1.5. So the value of x must be between 1.4 and 1.5. and then we can repeat this process again and again. Simon Stevin, he's the one that appears in the previous slide, the one using the IVT method. And this picture on the right is Simon Stevin. He was a Flanders mathematician and engineer. He was assumed to be born in Bruges, since he enrolled at Leiden University. Stevin grew up in a relatively affluent environment, and he enjoyed a good education because he went to university. And most of his work are written in Dutch, because he believes that Dutch is the most suitable language for interpreting signs. But he also wants to help people who don't understand Latin to learn signs. At his time, Latin is one of the noble language for people. Stevin, he wrote a book called Die Tiende in 1585 about decimal arithmetic. It is the first version of decimal notation that was established. He printed little circles around the decimal places while using several symbols for powers of x. But the negative exponents did not appear in his work, so he did not use negative numbers. In this example, he represents the decimals with a number with a circle around it. It's like 0, 5, 1, 4, 2, 2, 3, 9, and 4, 0. It's the placement of the decimals. And what about the other cultures at that time? The Babylonians. Babylonians used sexagesimal positional number system, which is base 60, and the position of the number due values in this notation system. And when we are studying them, we use comma instead of the slash and the semicolon for decimal to make it easier for us to understand. So they do have some way to represent the decimals in their culture. And for ancient Chinese, some of the practical units of measurements, they use decimals to represent. And the first written material, which includes clear decimal method, is written by Han Yan in the 8th century. But ancient Chinese people prefer to use language, not symbols, to represent the number. And this is my works cited page. Thank you for watching.